Okay guys, so in this lecture we'll be discussing about halogenation of alkane. Okay, so halogenation of alkane. Okay, so suppose we have something like, in presence of H nu, it will form something like CH3Cl plus HCl, and if we have plus in presence of H nu, it will have something like this. If we have so it would make Cl plus HCl. This is Cl. Okay, for this we have something like this, and plus Cl2 gives, in presence of H nu, it gives um, uh, I hope you are understanding why this product formation is there in this case. Okay, we will look into the mechanism of this halogenation in a little while. We have, for this we have, or we can also have okay, so if we have something like this, then CH3Cl will be formed, and if we apply sodium triether or Wood's reaction on it, it would become ethane. So we actually made ethane from methane. Okay, this is an important reaction. Now if we have something like, we have a benzene, and this benzene ring goes on to create two benzene, one more benzene is substituted to it, or phenyl ring substituted to it. So what would be the mechanism, or what would be the reagents you would have taken for this? So first I would have done halogenation. By halogenation I mean, first I would have reacted it with Cl2 to form a chlorobenzene, and then from chlorobenzene I would have done reacted with sodium triether to form this compound. So second is Wood's reaction. Okay, now let's take this example where we have a phenyl ring or benzene ring, and this is the reagent, this is the reactant, sorry, this is the substrate, and this is the product. So you have to tell how this product is formed from this reactant. So first what we will do is, we should have 3 carbon attached to this carbon in benzene ring, right? So it should have come from something like CH2CH2 CH2CH double bond CH2, and if we somehow get this substrate, we can easily react it with HBr in peroxide effect to form this compound, right? So how do we get this? So for getting this, we can actually react. How do we get this from our benzene ring? So for this we can actually react our benzene ring with CH2 double bond CH to Cl. So that would, in presence of AlCl3, that would actually, via Friedel-Crafts mechanism, it would actually have substituted CH2 double bond CH2 on benzene ring, right? So we got this, hence we'll actually use this reaction as the second step. This would be the first step. So from first step to go to the second step, and from second step you go to the actual product. Okay, so this is how we can make this product from this substrate. Okay, so let us talk about the mechanism of this halogenation reaction. So let's talk about the mechanism of we'll look as to how this is happening. Okay, so the first step is chain initiation step. So in chain initiation step we have two chloro groups. We pass HNO to it, so it will convert into two free radicals, two chloro free radicals. And the second chain propagation step, we would have something like this, and on which the free radical chloro will attack to form a free radical methyl free radical, and it will convert into HCl. Okay, and third, it is a chain termination step. So in this, what happens is we have CS3 free radical. So first CS3 free radical will combine with CS3 free radical to form CS3, as this was a free radical formed here. Okay, and it can also combine with Cl free radical to form this, and it can also convert the Cl can also have Cl2. So this is a major product of this reaction which we were looking for. Hence, by this, halogenation of alkane is done. Okay, so this completes our subtopic on electrophile, nucleophile, some addition reactions, nucleophilic reactions, substitutions, halogenations, Friedel-Crafts, Wurtz. So this is the end of this chapter, and from the next chapter we will be seeing into the optical stereoisomerism, and we'll be first taking out conformers. So good luck and see you in the next lecture.